Microcontrollers, part 12, definition of debugging, input and output, analog to digital conversion, timers and counters. Debugging is the process of identifying errors and either fixing them or bypassing them altogether. When creating a new program, click on New, Flowchart. This window sets the original settings for the PIC that we're going to be using. We can see over here that the template uses from C0 to C2 and then C6 and C7 as our inputs. Our outputs are from B0 to B7. If you look, C3, C4 and C5 are dimmed out. The reason for that is because those are the IC pins that we are going to use in order to program our IC, and these are also the dedicated communication ports in case the programmable IC needs to communicate back to the computer. Here we do have the ability to change the designation. In other words, there I have just converted C0 as an output instead of an input. But your design over here will be determined by the scenario required to program. Once you click OK, your new program will be ready and it automatically opens up with a start. Very important is your conversion from analog to digital. You click on the analog input, you drag it into your work surface, and when you double click on your analog command, it opens this window. So from this window we can now determine and say what is considered a 1 and what is considered a 0. 0 will give us a no answer and a 1 will give us a yes answer. That mathematical explanation over there gives us clear indication of what values we can expect. So when we go in there, we can now either slide this value and say anything below 70 is a 0 and everything above 100 is also a 0, and as a result from 71 to 99 will be considered a 1. Everything outside of that will be considered a 0. You are able to go and convert this. If we look at the slider over here, we see that it goes up to 255. The reason for that is this is a 5-volt supply IC, and as a result every voltage will represent, or every 1 volt will represent 51 volts. So if we want the circuit to trigger at 2 volts, then I will say 2 times 51, that gives me 102. So I can go in more detail there and say 102. So now it'll trigger at a value of 2 volts. Over here it will trigger at 5 volts again. This is the selection on which value we're looking at, but the B1 is an output, so we need to look at C as an input. When working with time, I need to go to variables. I click on time and then I can drag the time into my diagram. When I double click on time, I read there the command is there to enable or disable time incrementing. At this stage it is enabled, so this will now keep time. If we add a second one, I can double click it and I can say there the timer turns off. So this is useful in the process where we want to time how long it takes for something to occur. In the event that we need to do counting, we always use it with a compare value. So we're going to say increment. What that means is it adds 1 for every time it gets triggered. The properties variable, we're going to say where are we going to store that data, which is going to be variable A. Once we've done that, we're going to link it with the compare. The compare is there in order to tell us up to where are we going to count. It has to be equal to a certain value. The value it has to count to is, let's make it 20. And then we need to include a feedback loop. So from there, it has to feed back to the increment, and once it reaches 20, it needs to perform a task. So let's just simply put that as an output, but that has to swap. So it starts off at 0. We're going to have to write a value over there and say variable A becomes 0. So that's like the reset for this section. So there it becomes 0, and then it runs into this, and it's going to run through this loop 20 times, and once it's run through this loop 20 times, it then goes into this state over here where it's going to turn an output on.